What's up everybody, my name is Eric. Welcome to my channel, Eric the Tutor. What's up everybody, my name is Eric. Welcome to my channel, Eric the Tutor. Today we're going to be going through a Chem 118B Midterm 1 synthesis problems. Very highly requested video, so I made 11 examples. Try them out, give them a pause, unpause, and we'll talk through them together, alright? Let's go ahead and get started. So, number one here, we have triple bond, and I need to add on an R group on each side of my triple bond. So I need to do NaNH2, right? Because this guy is negative, is going to deprotonate. Got myself a nice lone pair here, negatively charged. And then from here, I can react with my C2CH5 group. And then in order to get to this final step, I'll do the same thing. I'll do NaNH2, and then I'll do a CH3Br. Right? Not too bad. Let's go ahead and move on to the next one. All right, for the next example here, very similar. All right, so from those steps, I'm going to get C triple bond C, and then I got my CH3 on the left. In order to get the group over here on the right, I want to deprotonate this guy, NaNH2, and then once it's deprotonated, looks like I'm going to react it with a carbonyl, CH3, just like this, and then let's leave an H right here, okay? So then when this guy comes in, this gets kicked up, and then I'm going to get, and then all I got to do to get to this last step is just simply protonate it. Let's keep moving forward. In order to get this right side, we already did that in the previous problem, NaNH2, step 1, step 2, I want to add carbonyl group, CH3, because I have a methyl group, and then an H, all right? And then, it's a little bit different actually, so let's go ahead and see what we get. So we get HC, triple bond C, and then we get, let's follow this up with some H3O+. Then we get our methyl group, and then we get an OH group. In order to get that carbonyl reformed, right, because I have a carbonyl, not an OH like in the previous example, I'm going to need to run this thing through some PCC. PCC, could have also done Jones, not going to matter here because it's secondary. We got a secondary alcohol, and just like that, we got our double bond O on the right side. All right, in order to get this thing on the left, it's looking a little bit more complicated, but actually should be fine. I think the next problem will be a little bit more complicated. Here, all we gotta do, NaNH2, deprotonate it, and then it looks like my double bond O has CH3 on both sides. So then I do this with some H3O+, and that should give me my final answer. Number 4 here, I know my first step. You guys should be comfortable with this. NaNH2, let's deprotonate one of the sides. How about we do the right side first? So in this case, notice you got the carbon here, let's call it carbon X. And then you got carbon 1, 2, and then an O, right? So right there, 1, 2, 3, if that was kind of together, right? I can connect 1, 2, 3 together. That's an epoxide. So in this case, you know, always have epoxides on your mind when you're doing these reactions, especially the synthesis problems. So if I react this guy with an epoxide, right, I'm going to need an epoxide. So let's get a little bit of O in here. Got a source of O up there. I see an OH group. Here's my O. One side needs to be bulkier than the other. Here we have two ethyl groups. And then one side we have just the methyl group, right? So therefore, this carbon is going to come attack the less hindered side because we have a strong base. So we're going to attack the less hindered side. And then just like that, carbon X hits carbon number 1, right? Carbon number 1 has a methyl. Here's carbon number 1. And then carbon number 2. Here's carbon number 2 with the two ethyl groups. And my OH group. Here's OH, right? Obviously, you do the epoxide and you do a little bit of acid workup to protonate that O minus. Perfect. Right side looks taken care of. To do the left side, same thing. Let's do NaNH2. Let's react it with an epoxide. So in this case, I see CX, 1, 2, O is number 3. So I'm going to do epoxide. In this case, off of number 1 here, I only have H's, right? No CH3 groups coming off. And then over here on number 2, looks like I also have, let's see, this should be, let's make this guy a CH3. Yeah, right there. CH3. Perfect. So now you have a deprotonated carbon on this side, right on the left. It's going to come hit the left side here. Here is number 1 and number 2. So let's see what we get. C triple bond C. I'm just going to put R on the right side for now because we know we just figured out the right side. Left side here was negatively charged. I hit carbon number 1. Off of number 1, no groups. Carbon number 2, I have my OH, right? Follow this up with some H3O plus. And then off of carbon number 2, I have a methyl group, just like that. Right? So here's 1, and then 2, and then there's the methyl. There's the O with the 3. And then simply to get to pretty close here to get to this final answer, I'm going to need to do some PCC. Let's protonate that left side. And then notice that we have a cis configuration. So in order to get cis, I'm going to do H2 and Lindlar. All right, let's go to the next problem. We got another good one here. Start this thing off by getting rid of that OH. We know with PBr3, we're replacing that O with a Br. If I do a little bit of base, let's do strong base, maybe LDA, I can actually make a nice double bond right here. Okay. Once we get that double bond here, it looks like I want that OH on the Markovnikov spot. So in order to get that, I can go ahead and do a Markovnikov. Let's just do, honestly, here we could do H2SO4, water and heat, or anything that can give you a Markovnikov OH in that location. So I could have also done oxymercuration, demercuration, oxymerc, demercuration. I think could have done some other things too, but essentially get your double bond there and then add your OH in the Markovnikov spot. All right, number 6 here looks similar to the last one. A little bit different though. Let's react this guy again with PBr3. Let's do LDA. A little different for this next step. I see that I need to add triple bond. All right. How about here? We're going to react this guy with MCPBA. Let's see what happens. It's more substituted than the other. So if I react this thing with a strong base, such as a triple bond, little propyl group here, get a negative charge on this carbon, then this guy can actually attack here, pop this thing open. We're going to get the OH in the place that we want. Number 7 here, I wouldn't be surprised if you saw something like this, right? Simply got Br2, HV. Okay, so we added our Br group. Now I want to do a little bit of LDA. Once I get that double bond, you'll see why I do ozonolysis next. I'm trying to set myself up for a Grignard reagent, so I can do C2H5Li or C2H5MgBr, and all of that's going to be in some H3O plus, right? Because I have 1, 2, 3 carbons, 1, 2, 3 carbons. I need to add carbon 4 and 5, so that's why I do C2H5. That's carbon 4 and 5. And we're basically coming in here, kicking this up, and then protonating that O. Let's go ahead and move on to number 8. notice how off of, let's just call this carbon number 1 and number 2, you always want to see what's coming off of each carbon. So off of number 1, I got an O. Number 2, I got a BR, right? Let's try not to make it too fancy. You could say C'10, but really the goal is seeing that there's an O on number 1 and on number 2 there's a BR. So if I react this group with Br2 H2O, I should be able to, we got carbon 1, 2, 3, 4. So we can see off of between 2 and 3, a BR is going to go on one of them. An OH is going to go on the other. Either way, we're going to be breaking that triple bond down into a double bond. And then off of one of them, we're going to have an O. And then off the other one, we're going to have a BR. Now notice, we're not quite at the final answer yet, but we know this will go through some tautomerization. If I put this in some acid, we know this is going to tautomerize, right? So make sure you guys practice that mechanism. I think that's definitely a fair game mechanism. Number 9 here, anytime you want to change your stereochem, so notice how we started off trans and then we become cis. Anytime we do that, you gotta essentially build it up to a triple bond and break it back down to a double bond. So this would be the same kind of style reaction if I was going from cis to trans. So essentially, this is preparation of alkynes. Make sure you guys review your notes. So if I do Br2 and some CCl4, I'll be able to add Br groups on both sides. Notice how I have an available hydrogen on each side here. So if I do NaNH2, right? Let's go ahead and do that 2 times. That's going to kick off a H, kick out a Br, kick out an H, kick out a Br. And then you're going to form a nice triple bond here, right? So pretty close. We got our 4 carbons. We're at triple bond. How do we go to cis? Well, all we got to do is H2 and Lindlar again. Right, you can imagine if we were going the other way, our final step, going from triple bond to trans. Just as a little side note, trans, I probably would have done Na radical and some NH3 liquid. This is a nice little quick one. If I react this guy with LDA, kick that group out, form a nice double bond here. And essentially, if we count our carbons, we got 1, 2, 3, 4, and 5. 1, 2, 3. Off of 4 and 5, I form an epoxide. All you got to do here is do a little carbene reaction, CH2, N2. I'm not sure if in this series specified in lecture, CH2N2 is going to end up forming some N2 gas, so maybe it's not as stable. So I also could have done C2I2 in CuZN, and that should give me the same answer. So this bottom one here is the Simmons-Smith reagent, but, should be fine. All right, just to wrap this guy up, we have 1, 2, 3, 4 carbons. Over here I only have 1, 2, 3. Looks like I'm adding a new carbon. So if I do Br2 and HV, get my Br here, do a little bit of LDA, get a little double bond. Then if I do Br2 and CCl4, across that double bond, I'm going to add 2 new Br groups. If I do NaNH2 3 times, it's going to give me a nice triple bond terminal. And then simply to get from here to here, all I got to react. This one was a little bit tricky, but you had to notice that this was actually just a formaldehyde. Most of the other examples I did were an aldehyde, maybe ketone or something, but here's formaldehyde, and then I do a little bit of H3O plus, and that should protonate that O minus. So then you have 1, 2, 3, you got your 4th carbon right here. Carbon number 4, and then off of 4, you got your 2 little H's. Perfect. All right, guys, thanks for tuning in. We'll see you next time.